Welcome students. In this video, we are going to see another set of instruction classification which is called arithmetical operation. So the instructions which are we are going to see was going to do arithmetical operation. Example, some addition, subtraction, multiplication, division, incrementation. All these arithmetical operations will be carried out using these kind of instructions. Okay. So first instruction what we are going to see was ADD of A comma Rn. So from all previous videos and instruction, we know that Rn represent register. A means accumulator. So ADD here represents addition of A register value plus this general purpose register value, and the result will be stored in A register. So example, suppose ADD of A comma R1. So what this instruction will perform means the value in A register and value in R1 register will be added, and then the result will be stored in A register itself. So that is nothing but A equal to A plus R1. That is what happening with this instruction. Okay. So simple example, if you assume A equal to 33, R1 equal to 25. So after the instruction will be doing A plus R1. So that means 33 plus 25. After executing this instruction, A will be having the result of these two addition and R1 will be having the same value. Okay, so A will be overrated. So this is what happens with this instruction. So next instruction, ADD of A comma direct. So we know that direct represents direct byte of the direct address of the data. Okay, so direct address is given here and A. So same thing will be happening here also. Addition will be taken place, but in this case the addition will be taken place between A register and the data stored in the memory location which is given here. So in this case 55 is the memory location. So whatever data stored in this memory location, that data will be added with A register value, and then the result will be stored in A register itself. So this is what happens, A equal to A plus data in 55 memory location. So this is another example. So suppose 30 A is having 33 and 55 memory location is having a value of 25. So addition will be happening like this, A equal to A plus 55. That means the value in 55 will be added. So 33 plus 25. Okay. So the result will be, so as I told you, this is the memory location and this is the data. Okay, this data will be processed. Okay, so after executing, A register value will be having the result of these two values, and 55 memory location will be having the same value. It will not change. Okay, so this is what happens with this instruction. And another instruction is ADD of A comma at of Ri. So here we are going to dealing with indirect register. Okay, that means register will be holding the address of the data. Okay, so from the example you will understand clearly. So ADD of A comma at of R2. So here R2 will be having one value. That value will be considered as an address for the data. Okay, so that data will be added with data in A register and the result is stored in A register. Okay, so A equal to A plus data in memory pointed by R2. Okay, so R2 is pointing a memory location. That memory location data will be processed. Okay, simple example, suppose R2 is having 55. This 55 will be considered as an address of the data. Then a data from that address will be taken care. Okay, so this is what happens here. Okay, suppose A equal to 33. So here indirectly we are taking this 25 and these two will be getting added. So after executing the instruction, you will be having R2 value will not change and 55 memory location value will not change. The result in A register will be changing. Okay, 58. Okay, because this is the result of these two values addition. A value is 33 and 55's value is 25. So those two values are added and the result is stored here. Okay, so this is what happens with these two instructions. Next, ADD of A comma hash data. Here what we are doing was we are adding the data with a register value in the immediate mode. That means this 25 will be considered as a data. Okay, so what will happen? A plus 25 will be happening. 25 here is data only. It is not any memory. It's direct data. Okay, we are giving immediate data in the instruction itself. So 33 is, if you having a value is 33 and a equal to a plus 25, that means 33 plus 25. Since this is data itself, so we are adding the data with a value itself immediately. So result will be 50. There is no register involved in this. There is no memory involved in it. Okay. Data and the value in accumulator. That means a register. That's all. Okay. So ADDC A comma Rn. So in previous instructions, whenever there is a result comes after addition, before these instructions, if you see whatever instruction we have seen, in these instructions, whenever the result is coming, a PSW will get affected. According to the result, a PSW will get affected. That means either carry flag will set or auxiliary carry flag will set. It depends upon the result. Okay. So here what we are going to see was ADDC of A comma Rn. So what is happening means we are going to add the A value, that means A register value, and also value in general purpose register, and also the carry information. Okay, so that is what happening here. So example, ADDC of A comma R1 means A equal to A plus, that means value in A plus value in R1 plus what is the carry flag information. Okay, so what is the carry flag information right now? That carry flag information also will be added in this. Okay, so we can see the example. Suppose if you are having A value is 33 and R1 is 25, assume that carry flag right now is 0. Okay, there is no carry flag is right now is 0. So what will happen? 33 value, that means from A, and 25 from R1 and 0 from the carry. All three will get added and the result will be updated in A register. So it will not affect carry flag or it will not affect the register also. Okay. After adding this result, if there is a carry means then the carry flag will set. Okay. So that depends upon the outcome of the result. Okay. So this is what happens with this instruction. Okay. Same ADDC of A comma direct. So already about direct we have seen so many examples. So we can see the example directly. So A equal to A plus data in the direct memory location plus carry information. So assume that A value is 33 and the value stored in 55 memory location is 25. Assume here currently carry is 1. Okay, so just simple assumption. Currently carry is 1, that means carry bit is already set. Okay, so then it will add A plus 55 plus carry, so 33 plus 25 plus this carry information also will be getting added. Okay, so now the result will be with carry information. Okay, so that is ADDC. Okay, so this is what happens in most all the instructions. Okay, so here also we can see R2 at of R2. So we know that at of R2 means what it represents. Here ADDC we have given, so carry information will be added extra. Okay, so this is what happens here also. Okay, so please go through this. These R2 value, what happens to R2 we have already seen in so much of examples. Okay, only difference in this instruction was we are going to add a carry information also. Okay, so the carry information whatever during the execution, that carry information will be included in the addition process. Okay, so that is what happens with ADDC. Same. So here also ADDC A comma hash of 25. So hash of 25 means 25 is the immediate value. So that A value will be added with 25 plus carry value. Okay, so that is what happens here also. Okay, so many times we have seen all these hash everything. So I am just go through what is happening here. Okay, so a value is 33 and carry value is 1. So a value plus this 25 is immediate value and then carry value. So that will be added. Okay, so the result will be with the carry information. Okay, so that is what happens here. Okay, so next instruction is SUBB. A comma RN. So we know that SUBB means subtract with borrow. There is no instruction of subtraction without borrow. Okay, so there is an addition without carry you can add. Okay, but without borrow you can't subtract. In 8051 all the subtractions are with borrow only. Okay, so what is happening here? We know that subtraction means what? So it will subtract a value and this register value. Okay, a value and this register value. Here since subtract with borrow is given, it will subtract with the carry information also. A minus R1 minus CY. Carry information also will be getting subtracted. Okay, so suppose if 33 is the value, assuming R1 value is 25 and carry information is 0. So what will happen? 33 minus 25 minus 0 will be happening here. Okay, so previously we have seen ADDC. So that is addition with carry. Here subtraction with borrow. Why we are saying borrow? So whenever there is a borrow in it while subtraction, the carry will be generated. Okay, so that's why we are subtracting with borrow. Okay, so it will subtract with borrow only. That means borrow in the sense carry information. That is called borrow. Okay, so carry will be 0 means it will also will be included in the subtraction. Okay, so this is our value. 33 minus 25 you will get 0e. Okay, so that 0e value, since carry is also 0, so 0e you will get. Okay, so this is what happens with SUBB A comma R1. Same SUBB A comma direct, which is nothing but subtract with borrow with respective of A register and the data in 55 memory location. So which is nothing but A equal to A minus data in 55 memory location minus carry information. Just an assumption. Example, suppose A is having 33, 25. If carry is 1, suppose. Okay, so answer will become 0D because this carry also will be included in the subtraction part. So 1 will be minused. Okay, so this is what happens with the subtraction. Okay, same. This is negative. Okay, so A minus data in memory pointed by R2 minus carry. Okay, so that is what happens here. This is plus, not this is not plus, this is minus. Okay, so minus subtraction will be happening here. So assuming this is indirect addressing, using indirect addressing, how the subtraction with borrow will be happening. Thus example I have given here. Okay, so this is what happens after executing of instruction. Okay, so subtract with borrow with immediate data. Okay, so immediate data means you will be having a data in the instruction itself. So this is what happens. A equal to A minus 25 minus carry information.